Good evening, Paluki and others watching this video. My name is Shanisa, along with my group members from Group B, and today we'll be explaining about our final project, which is called 6 Pokemon 7, a Kalos region Pokemon navigation system that takes into consideration about geographical real-life structures. So our program basically uses Pokemon as a substitute for real-life vehicles, along with a few regions in Kalos to sit as an abstracted method to see what the program would be like for real life travel purposes.
Okay, hello Mr. Rocky. My name is Banavara Natala, and I'm going to explain the output of our code. So to compile the code, we have because we use header files, we have to compile all of the files first, then the main file, so we can use all the functions of the previous files into the main files. So like this, and wait for it. Nah, 6 Pokemon 7 showing, and it's going to build the system. Loading successful, and it's done. 6 Pokemon 7, Kalos travel navigation. So we have 6 options. First, let's see option 1, view Kalos map. And here, 6, it shows the region of Kalos with its map. There's 12 area with 14 route. And here we can see the route terrain from the map. So for action number 2, the Pokédex. And see in the Pokédex menu, we can search Pokemon by name, search Pokemon by index, and Pokemon type 3. Let's see search Pokemon by name first. For example, let's see Pokemon Lapras. And here, the system will show that there is a Pokemon named Lapras at index here, 0131, and its type is ice and water. But for example, if we include a Pokemon that is not in the database, let's see, like Mew, it will show there's no found. It doesn't found Mew in the database. Okay, for sorting Pokemon by index, when we input to, it to show all the Pokemon by index in the descending order. No, ascending order. Ascending order. From Charizard 006 to Hoopa 07 to 0. And for the Pokemon type 3, uh, here we can see the Pokemon has several types. Let's see, type Dragon, type Dragon, Dragon. And the system will show all the Pokemon that has the attribute Dragon. And if we input all, it will show all the Pokemon types. Okay, let's exit from the Pokédex. Wait. Now we will use the find the shortest travel route from the map. Let's see. Let's try from Lumia City and to the location. Let's see. Tower of Mastery 9. And here it will show the route from Lumia City to Tower of Mastery. And it will show the area and the route. And now the fun part, this program will start the interactive journey of the 6 Pokemon 7 Kalos Travel Navigation. Okay, so starting location, the same, Lumia City to Tower of Mastery. And here, The journey has started from Lumia City to Tower of Mastery, and currently we are on Lumia City. And here it will show the available routes to the nearby area of Lumia City, and it will also show the compatible Pokemon that we can choose to accompany us to the certain area. So maybe let's see. Let's try Geosense Ruins. For the Pokemon, let's try Rotom. And now we have, and now let's say that it will display the block routes that we cannot, apa namanya, we cannot travel to with our Pokemon. It will update our current location, and here you can see that there is Tower of Mastery on option 2, so we'll pick that, and we'll choose a Pokemon again. Let's see, maybe Hoopa. And now we'll show destination reach and the journey summary of our journey. And to see again the journey, we can access the journey log and uh, show all journey logs. They'll say the journey log by ID 001. So by log ID 001. And it will show what path we took to the destination. And that's all from the code. Let's explain the intricacies of the code by Muhammad Dafian.
Okay, so first of all, the first function will be the BFS file. So the BFS files are used for the shortest route, and the program treats each Kalos location as a node and each route as an edge. BFS uses a queue to explore the graph level by level, allowing the program to find the shortest path between the starting location and the destination. Okay, here's the code run by Bana Farhan. Then there we'll go to the DFS files. Okay, so the DFS files are used for the interactive journey feature. The program checks available routes from the current location and determines which Pokemon can traverse each route based on type and terrain compatibility. DFS is also used to explore reachable location using a selected Pokemon. Okay, next.
And then I will explain about the constants folder first. Go to the constants, the data.h. So data.h uses the header file, which is sort of a declaration so that the whole program will know that the data.cpp file exists. Therefore, we can also access inside the vectors or the global data vectors that are inside the file, which is for the Pokemon's locations, routes, and then, yeah, this is to ensure efficiency since our program uses the same data over and over again. It also uses the extern declaration for Pokemon locations and routes. So our data in the data.h file, so our program can access all the vectors that are previously shown. And then there's also the menu.h and the menu.cpp, with the menu.h being the header file and the menu.cpp being the main script and the code itself. This is to sort of show the animations of the login screen as well as the actual main menu, so the user can traverse through our program more effectively and efficiently as well, as shown over here. We also use libraries such as Chronos and Fred to for sort of a did that, so the program won't immediately load everything, but there will be intervals between the code. It's for a sort of an animation. And then the travel log, sort, search, entry will be explained by my group members. And there's also the mathgraph.cpp and mapgraph.h. below DFS over there. This is just to show the user of like the map of Kalos itself or the chosen locations of Kalos. Basically, a graph where each city is a node and they're connected through a route with where each route has its own specific type of terrain which certain Pokemons can enter. And then mapgraph.h is basically just to declare the mapgraph.cpp to the rest of the file so the program can access it. And then continuing to search.cpp.
Okay, so for search.cpp and search.h, first the search.h is it declares all the library and this one what it do is turns the uppercase letters to lowercase. So there's no so the program is not case sensitive when searching for a specific Pokemon from the Pokédex. And here in the program search, you can see that it turns the uppercase letter to lowercase, and it uses a for loop to check every letter of the input and to compare them to the Pokédex uh, Pokédex the Pokédex file from the data.cpp. And if it doesn't match found it will display no Pokemon found from the query that is inputted from the user. And we continue to sort.cpp and sort.h. Sort.h will again declare all the library, and in here sort.h will format the type so can sort it. We will use quick sort for this. As in compare by index, it will compare the largest and the lesser one. And here we use a partition and all of that, and we use a quick sort to sort the Pokemon index from the smallest to largest. And into the travelogue.cpp, explained by my group member.
Okay, so there is the Travelog CPP. The Travelog files implement hashing. Each complete journey is saved with a generate journey ID, such as G001. Oh wait, where's G0? Yeah, such as that. The journey ID is converted to a hash table index using a hash function. There's the hash function, and this allows the program to store and search journey records efficiently. And for each journey log contains the start location, the destination location, the road steps, terrain, and what Pokemon is used. Okay, nice.
Okay, last for tree.cpp, it will convert for tree.h, the tree node, it will make the tree node. Here, we have no left or right because we'll make an array tree, so there will be many children of the root. And this is the functions, and to tree.cpp, we'll use okay, so this function to uh, clear the tree, and is for display. There's for loop to display the tree, and this function group and display by type. It will make the Pokemons from this vector into a tree. It will turn that into tree from with making the Pokédex the root of the tree. So Pokédex, and there will be many types that will be the children of the Pokédex. And then it will ask for input for what Pokemon type, And if the user type all, it will display all of the tree. And if user only input one type, it will only display one type of tree.
Okay, continuing on to the models file, which is basically only contains the struct.h because it's only for defining the custom data types used for the whole program. This is to ensure that the data of our program is more organized and easier to manage. There's location for the location index and the name, just like for example Lumio City, and then the different types of routes from the previous location and where it goes to and the type of terrain that's in. And then we also have the start journey step. This is for the hash, which has the previous location and then the destination location, the type of terrain, and the Pokemon that the user used to go to that location. This is for the travel history. And then there's also the journey log, which is all the to put the data of the journeys that we went through from the DFS interactive journey. Okay, and then finally, there's the main.cpp file. This is basically the main part of our program, which has all the libraries that we use. This is only for the other files. So our program will know that they exist and can access the data and the codes in there. So it will tell the user using a do while loop. The user will then just loop through the main menu and choose which actions they want to do using the switch case function. And unless the user types 6 or to end the data, that to end the program, then it will just keep looping. And that's it. Once they type 6, the program will end. And that's the entire part of our 6 Pokemon 7 data. Thank you, sir. Yay.